Two air conditioners may have the same cooling capacity, but their electricity consumption can be different. One air conditioner may consume more electricity, while another may consume less electricity, to provide the same amount of cooling. One of the main reasons for this difference is the energy efficiency of the air conditioners. The energy efficiency ratio, or EER, helps us understand this efficiency. One AC unit may have a higher EER value, while another may have a lower EER value. The EER of an air conditioner is similar to the mileage of a car or motorcycle. In a vehicle, mileage tells us how many kilometers or miles the vehicle can travel using 1 liter or 1 gallon of fuel. Similarly, EER tells us how much cooling an air conditioner can provide using a particular amount of electrical power. But what do we mean by cooling? Here, cooling refers to the cooling capacity of the air conditioner. The cooling capacity of an AC unit is usually mentioned in BTU per hour, tons of refrigeration, or kilowatts. For example, let us take an air conditioner with a cooling capacity of 12,000 BTU per hour. Assume that this air conditioner consumes 1.1 kilowatts of electrical power, which is equal to 1,100 watts. This is similar to calculating the mileage of a vehicle. For a vehicle, we calculate how much distance it can travel using 1 liter of fuel. For an air conditioner, we calculate how much cooling it can provide using a particular amount of electrical power. The formula for EER is EER equals cooling capacity in BTU per hour divided by electrical power input in watts. Therefore, 12,000 BTU per hour divided by 1,100 watts equals 10.9. So, the EER value of this air conditioner is approximately 10.9. A higher EER value generally means that the air conditioner can provide more cooling while consuming less electricity. However, when comparing EER values, we should compare air conditioners of the same type, similar capacity, and the same testing standard. Now, instead of using BTU per hour, we can express the cooling capacity in kilowatts. A cooling capacity of 12,000 BTU per hour is approximately equal to 3.52 kilowatts of cooling capacity. Now, let us calculate the efficiency again. 3.52 kilowatts of cooling divided by 1.1 kilowatts of electrical power equals 3.2. When the cooling output and electrical input are expressed using the same unit, the resulting value is called the coefficient of performance, or COP. So, the COP of this air conditioner is approximately 3.2. A higher COP value also generally indicates better efficiency. Therefore, EER and COP are both used to represent the efficiency of an air conditioner. EER normally compares cooling capacity in BTU per hour with electrical power in watts. COP compares the cooling output and electrical input using the same unit, such as kilowatts. That is the basic meaning of the energy efficiency ratio, or EER. What is SEER? The full form of SEER is Seasonal Energy Efficiency Ratio. SEER is also used to represent the efficiency of an air conditioner, but it is calculated differently from EER. Let us again use a vehicle as an example. Imagine that a car gives a mileage of 18 kilometers per liter or 18 miles per gallon. The car may not provide exactly the same mileage under every driving condition. Its mileage can change during city traffic, highway driving, low-speed driving, high-speed driving, and stop-and-go driving. By considering the fuel consumed under different driving conditions, we can calculate the average mileage of the vehicle. SEER works in a similar way for an air conditioner. The EER of an air conditioner is measured under a particular fixed indoor and outdoor temperature condition. Under that fixed condition, the electrical power consumption of the air conditioner is measured to determine how much energy is required to provide a particular amount of cooling. However, an air conditioner does not operate under the same temperature and cooling load condition throughout the entire cooling season. The outdoor temperature changes, the indoor cooling requirement changes, and the air conditioner may operate at full capacity or partial capacity. Therefore, to calculate SEER, the air conditioner's performance is tested under different outdoor temperatures and cooling load conditions. The total cooling provided throughout the cooling season is then divided by the total electrical energy consumed during that season. The result is called the Seasonal Energy Efficiency Ratio, or SEER. So, EER tells us the efficiency of an air conditioner under a particular fixed operating condition. SEER represents the average efficiency of the air conditioner under different operating conditions throughout a cooling season. When buying an air conditioner, we can compare two units with the same cooling capacity. An air conditioner with a higher EER or SEER value will generally provide better energy efficiency and consume less electricity for the same cooling requirement. However, the efficiency values should be compared only between units of a similar type, capacity, and testing standard. The EER and SEER ratings of an air conditioner depend on the complete design of the system. Efficient compressors, inverter or variable speed technology, properly designed evaporator and condenser coils, efficient fan motors, electronic expansion valves, accurate sensors, proper airflow, and good control systems can all contribute to better efficiency. Proper maintenance is also very important. Regular maintenance helps the air conditioner operate closer to its rated efficiency. Dirty air filters, dirty evaporator or condenser coils, restricted airflow, incorrect refrigerant charge, and damaged components can reduce the actual operating efficiency of the air conditioner. Therefore, a higher EER or SEER value basically means more cooling with less electricity consumption. There is one more important point. Throughout this video, we have said that an air conditioner uses 1.1 kilowatts of electrical power to provide 12,000 BTU per hour of cooling. However, technically, an air conditioner does not generate cold air or create cooling. It removes heat from the indoor space and transfers that heat to the outdoor environment. When the air conditioner removes heat from the room, the amount of heat inside the room decreases. Because of this reduction in heat, we experience a cooling effect. I used the phrase providing cooling only to make the explanation easier to understand. That is all for this video. If you found this video useful, please like it and share it with anyone who may benefit from this information. Also, do not forget to subscribe to our Zebra Learnings channel. Thank you.